Have you ever just stopped and wondered how your smartphone knows exactly what to do when you tap on an app? Or how a microwave gets your food just right? It really feels like magic, but it's not. It's actually a secret language, and it controls pretty much everything around us. And today, we're going to decode the basics so you can start to understand it too.
First up, let's talk about where this stuff actually lives. Because programming is literally everywhere, often in places you would never, ever expect. And once you start looking for it, you realize just how many of our daily gadgets are just, well, they're waiting for instructions.
So just think about this for a second. From your smart TV to your washing machine, what's the one thing that connects all of these different devices in our lives?
Okay, so we've got the obvious tech, right? Things like computers and smart TVs. But what about a washing machine? Or your fridge? Or, get this, even a modern sewing machine? They all seem like they're from totally different worlds, but they all share this one powerful, invisible connection. And that's it. That's the secret. Every single one of them, from the most complicated gadget you own to the simplest, runs on programming. It's the invisible blueprint that tells them exactly how to function.
So that brings us to the really big question. What is programming, anyway? Let's break it down into its simplest parts, because it's not as scary as it sounds.
All right, to get programming, you first have to kind of expand your idea of what a computer is. Forget the box on your desk for a minute. A computer is any device that can take in and process information. That microwave? Yep, it's a computer. Your smart fridge? You're looking at another one. Which leads us right here. If all those things are computers, then computer programming is just, well, it's the act of writing the instruction manual for them. It's how we tell the machine what to do, whether that's heat my coffee for 90 seconds or wash my clothes on the delicate cycle. At its heart, that's all it is. Programming is just the language we use to tell machines what we want them to do. It's as simple as that. It's communication. Okay, so if programming is all about giving instructions, how do we make sure they're perfect? Machines can't guess, they can't fill in the blanks like a person can. Every single instruction has to be incredibly precise. Think about it. How would you write instructions for a robot to make a sandwich if that robot has never even seen bread before? You'd have to be ridiculously specific, right? Pick up the knife, move the knife to the jar. That's the real challenge here. And the answer is something called an algorithm. Now I know, that sounds like a really complex, technical word, but I promise you it's not. An algorithm is just a fancy name for a step-by-step plan. A clear, ordered list of actions to get something done. And here's the funny thing. You use algorithms all the time without even realizing it. A recipe to bake a cake? That's totally an algorithm. The instructions for building that bookshelf you bought? Yep, also an algorithm. The idea is already second nature to us. Here's a perfect non-techie example. An algorithm for planting a seedling. Every single step is a clear, simple action. There's no room for confusion. And the order is absolutely critical, right? You can't compact the soil before you put the seedling in the hole. It makes no assumptions. This is exactly how a computer needs instructions. And this diagram really shows it perfectly. Just look at the structure. It's a pure algorithm in action, just a logical, step-by-step plan. Believe it or not, every single piece of software ever written started with a simple plan just like this. So, we have our plan. That's the algorithm. But how do we turn that plan into something a computer can eventually understand? Well, that brings us to our next step. This is where a really cool tool called pseudocode comes in. Think of it like this. If the algorithm is the idea in your head, or maybe a quick sketch on a napkin, pseudocode is the first neat, organized draft of that idea. The name kind of gives it away, right? Pseudo means fake, so it's fake code. It uses keywords and a structure that looks a lot like a real programming language, but its main job is to be easily read by people, not machines. It's the bridge that gets us from a human plan to the computer's instructions. Okay, now check this out. We're seeing that same seedling algorithm, but now it's written as pseudocode. See how it's changed? You can see these command-like words that start each line, creating a much more formal, structured list. It's getting us one step closer to what real code looks like. So let's just make this crystal clear. An algorithm is the what, it's the logical plan, and pseudocode is the how. It's the structured, written-down draft of that plan, getting it ready for the next stage. And that's really the biggest takeaway here. Before anyone ever writes a single line of real computer code, programming begins with a simple, human-readable, logical plan.
It's not about some kind of secret magic. It's just about clear, step-by-step thinking.
So I'll leave you with this. We've figured out that an algorithm is basically just a recipe. Think about your own day for a second. What's a recipe you follow every morning to make your coffee, or a process you use to get ready for work? If you could write that recipe for a machine, what would you teach it to do? Because that's all programming really is. It's teaching, and the possibilities there are absolutely endless.